Hello everyone! Today we're going to talk about transport mechanisms. We're going to discuss how molecules can pass through cells. But first, let's talk about what makes up a solution. A solution is usually made up of two parts, a solute and a solvent. A solute is what gets dissolved in a solvent. So let's say you have a glass of water. The water would be the solvent, and if you add to that glass of water some salt, the salt would be the solute. The first transport mechanism we're going to discuss is diffusion. What is diffusion? Diffusion is basically the movement of the solutes from high concentration to low concentration. Let me give you an example so it would make more sense. Let's say that you spray some perfume in the room. The perfume molecules are not going to stay stationary. They're actually going to start diffusing. They're going to diffuse throughout the room. They're going to move from the high concentrated area to the low concentrated area until the perfume molecules are evenly distributed in the room. Or we say until equilibrium or balance is reached. Let's take a look at this image right here. You can see that in this image right here, you have a glass of water, and you went ahead and you dropped a few drops of dye into that glass of water. Now notice how the dye molecules are concentrated in this region right here. So they are highly concentrated. What's going to happen is that they're going to start dispersing or diffusing from the high concentrated area to the low concentrated area until equilibrium is reached. And that is diffusion. Now, what does the word concentration gradient mean? A concentration gradient means that you do not start with equal concentrations, meaning that right here you have the dye concentrated in this region, while the rest of the beaker does not have any dye. So those two regions right here are not equally concentrated. You have a high concentration of dye right here, while on this side you have zero dye. So as long as you have a concentration gradient, the molecules are going to keep dispersing themselves until you have the molecules evenly distributed. Diffusion is a passive transport, meaning that no energy is required. Diffusion can take place within our cells. We know that our cells are surrounded by a plasma membrane. So let's go ahead and take a look at this image right here. You have a part of the plasma membrane right here drawn out for you. And you can see that, let's say this is outside the cell, and this is the condition inside the cell. Now, if we compare those two sides, we see that we do have a concentration gradient. We don't have an equal concentration of those molecules. Now, notice how up here the molecules are highly concentrated. So if those molecules are to move, those molecules are going to move from the high concentrated region into the cell through the plasma membrane to the low concentrated region. So they're moving from high concentration to low concentration. And we say that those molecules are moving down the concentration gradient, or basically they're going with the flow from high to low. And that does not require any energy. Same thing right here. Let's say those molecules want to exit the cell. They're going to exit the cell directly through the plasma membrane from a high concentrated region to the low concentrated region. And again, no energy is required. Now, how can these molecules pass through the plasma membrane right away? Those molecules are usually small in size. So the smaller the size of the molecule, the easier it would be for the molecule to pass through the membrane. But what if you have pretty large molecules like most of our proteins? The thing is, the larger the molecule, the harder it is for it to pass directly through the plasma membrane. Because it's pretty large, it might get stuck. So those larger molecules right here would need the help of certain proteins, and those proteins, we refer to them, for example, as channel proteins. And there are so many different types of channel proteins. We also have some proteins known as carrier proteins, but the idea behind those channel proteins is that those channel proteins are basically going to act as channels or gates, allowing the large molecules to easily pass into or out of the cell. Now, let's take a look at how the molecules are moving. Are they going from high to low? Yes. Notice how they're going from the high concentrated region to the low concentrated region. And so, one more time, that is a passive transport. It does not require any energy. Now, if the molecules pass directly through the plasma membrane, we refer to that as a simple type of diffusion. But if the molecules require assistance of those facilitated, I just said it right there, they need assistance to pass through, so they need the help of those channel proteins. We refer to it as facilitated diffusion. Okay, now let's talk about osmosis. Osmosis is a passive transport, so no energy is going to be required. And osmosis is the term that we use to talk about the diffusion of water. Water likes to dilute things, so it likes to move from a region that has a high water concentration to a region that's pretty low in water. Or you can think of it in another way. Water moves from a region that has lower solutes to the region that has the higher solutes. Let's give an example. Let's say that I have two sides, side A and side B. And those two sides are, let's say those two sides are divided by a semi-permeable membrane. So here is my semi-permeable membrane, here is side A, and here is side B. And let's say that semi-permeable membrane only allows water to pass through and not any solutes. Let's say on side A, you have your solutes, so my circles are my solutes, and I do also have some solutes on side B. So both sides have solutes and both sides have water. And only water is, let's say, allowed to pass through that semi-permeable membrane. So how is the water going to move? Is the water going to move from side A to B or vice versa? So let's see, where do we have more water? The region that has the lower solute, which is right here, the lower the solute, is the region that has the higher water concentration. Versus inside A, we have a higher solute concentration. And if you have a higher solute concentration, that means the water is not that highly concentrated. And so the water is going to move from side B to side A, because water likes to go from a high water concentration to the lower water concentration, or basically from the side that has lower solutes to the side that has the higher solutes, because it would want to dilute side A. Okay, let's take a look at this tube right here. You see that this tube, it's divided by a semi-permeable membrane. So we have two sides, side A and side B. If you take a look at side A, you will notice that side A has a lower solute concentration. And if it has a lower solute concentration, that means that side A has the higher water concentration. And so water always likes to move from the high water concentration to the low water concentration. And so therefore, the water is going to be moving from side A to side B. And so if you take a look at this image right here, you notice that side B, the water level is going to basically rise because the water is moving from the high concentrated area to the low concentrated area, or from A to B. And the water is going to actually keep moving to side B until equilibrium is reached, until both sides have the same water concentration. Tonicity is the term that we use to describe a solution, and we use it to describe how that solution is going to affect a cell if that cell were to be placed in that solution. So let's say that you have a solution, and this solution has way more solutes compared to the cell. What are we going to call that solution? We call that solution a hypertonic solution. And actually the word hyper means high. So a hypertonic solution has a higher solute concentration in the solution compared to the cell. Let's say you have a solution and that solution has a lower solute concentration compared to the cell. We refer to it as a hypotonic solution, and hypo means low. So the hypotonic solution has a lower solute concentration compared to the cell. If you have a solution that has the same concentration of solutes in that solution and in the cell, then we refer to that solution as an isotonic. Iso actually means the same or equal. So you have the same amount of solutes inside the cell and in that solution. So those are the three terms we use to describe the solutions: hypertonic, hypotonic, and isotonic. Okay, with this image, we're going to see what's going to happen to a cell if a cell was to be placed in different types of solutions. Let's actually start with that middle picture right here. Let's say that you have an animal cell, let's say a red blood cell, and you took that red blood cell and you submerged it in a hypotonic solution. Remember how we said hypo means low? So that means that outside this cell, you place that cell in a hypotonic solution, which means that this solution has a lower solute concentration compared to your red blood cell, and it also means that this solution has a higher water concentration. And as we talked about osmosis, we said that water likes to move from the high water concentration to the low water concentration. And so what's going to happen, the water is actually going to start entering into the cell. Why is the water going to be entering into the cell? Because outside the cell, you have a higher water concentration, and water likes to go from high water to low water. Now, if this continues to happen, your cells are actually going to take in too much water, and they will swell to the point that they might burst. What happens if you take your red blood cells and this time you placed your red blood cells in a hypertonic solution? If you place your cells in a hypertonic, that means that this solution outside has what? A higher solute concentration. But what does that mean about the water? That means that outside your cell, there is a lower water concentration. So is the water going to be moving into the cell? And the answer is no. Because now, where do you have the higher water concentration? You actually have a higher water concentration inside the cell compared to outside. So what's going to happen is that you're going to notice that the water is going to start rushing out of your cells, because it's moving from a high water concentration inside your cell to a low water concentration outside your cell. And if this continues to happen, then that's problematic because your cells are going to start shriveling up because they're losing too much water. What if you place your cells in an isotonic solution? Remember how we said iso means you have equal concentration of solute and equal concentration of water inside and outside your cell? So is the water going to move at all? Yes, the water is going to move, but you will notice that the water is going to move in and out at an equal rate. And so therefore, nothing is going to happen to the size of your cells if it was to be placed in an isotonic solution. And so when a patient goes to the hospital and they hook them up to an IV bag, the best IV bag to be hooked up to would be an isotonic solution because you don't want anything to happen to the size of your cells. Now, if we take a look at plant cells, you will notice that actually plant cells do better when they are in a hypotonic solution. That makes them look actually much more fresh and healthy, and they stand up straight. So plant cells actually like to take in a bit more water, and if you remember, they will store that water in their central vacuole. The idea of how laxatives actually relieve constipation actually has to do with the movement of water, with osmosis. So when you ingest those laxative pills and they go inside of your intestines, so let's say we have two sides, here is inside your intestines and here is outside. So when you ingest those laxative pills, what you do is that, so I'm just going to LAX as the laxative. So the thing is, you are going to increase the solute inside of your intestines compared to outside, because now all of those laxative pills are, you've ingested them, and so they are inside of your colon. And so the amount of solute is going to be pretty high inside of your intestines now compared to outside. And so what does that mean? Where do we have now more water? That means that you have a higher water concentration outside your intestines compared to inside. And so one more time, how is the water going to move? Water likes to go from the lower solute concentration to the higher solute concentration, or basically from high water to low water. So you're going to notice that water is actually going to start rushing inside of your intestines. And when the water rushes into your intestines, whatever blockage you have in there, as the water starts to rush in there, it's going to help push whatever blockage you have and basically helps you have a better bowel movement. So this image right here, it summarizes the passive transport, and we said that the passive transport, we talked about two types of passive transports, diffusion and osmosis, and we said that with diffusion, we have simple diffusion, the molecules are passing directly through the plasma membrane, or you can have facilitated diffusion, the molecules are passing through those channels. And those two types of diffusions are passive, no energy is required because the molecules are always moving from high concentration to low concentration. Osmosis is also passive because the water is moving from high water concentration to low water concentration, and so that does not require any energy either. Do not get confused by looking at this image and going, well, isn't water going from a low solute to a high solute? So how come that is still passive since we're going from low to high and not high to low? The thing is, yes, water is going from a low solute to a high solute, but it's not the solute that's moving, it's the water. And the water is still going from high water to low water concentration. When we look at the other type of transport out there known as active, active means that it does require energy. And the reason why it needs energy, because the molecules are actually going against the flow. They're moving from a low concentration to a high concentration. And if they are going to go against the flow and go from low to high, energy is going to be required. There's another type of transport known as exocytosis. Exo coming from the word exit. And so exocytosis is going to take place within a cell. Let's say this cell has a large bulk of molecules that need to be exported out of the cell. The cell is going to place those molecules in a vesicle, and as you can see, this vesicle gets really close to the plasma membrane. It actually merges with the plasma membrane, and the plasma membrane allows those molecules to exit out of the cell. Endo, on the other hand, is a process for the cell to intake large bulks of either food or fluids. And if the cell is going to take large bulks of food inside of it, we actually refer to it as phagocytosis. If the cell is to intake large amounts of fluid, we refer to it as pinocytosis. And you can see that the plasma membrane starts to dip inwards. The molecules get into that part of the plasma membrane that's now dipping. And the plasma membrane keeps folding around those molecules, and part of the plasma membrane actually gets pinched off, and those molecules would now be inside of the cell.